Hello everyone. Now today we are going to see some complicated type of problems that I already told you that type of problems in which resultant will be given and we will have to calculate any one of the missing force from the force system. So for that, suppose we are going to take one example. In this question we have to find out the find forces P and Q such that the resultant of given system is 0. It means what here this force P and Q we have to calculate. So whenever this kind of problem comes, you need not to worry about what additional things we have to find out or any alternate method is there. Simply whatever method we have used, the same method we have to adopt and we have to go ahead with whatever parameters we are getting, and with that thing we will automatically come to know with some of the equations, and with the help of that equations we will get the final answer. Okay, now suppose in our conventional method for solving this problem or for getting the resultant of a force system, we generally calculate first of all theta, okay, and that is with respect to x-axis. Okay, then in second step we generally resolve all these forces, that is we generally calculate or resolve forces into its x component and y component by using f cos of theta and f sin of theta. Then after that we used to calculate sum of all forces in x direction and sum of all forces in y direction, and after that in fourth step we usually calculate the resultant by using formula under root of summation of f of x square plus summation of f of y square, and theta as tan inverse of summation of f of y upon summation of f of x. Now here in this problem the data available with us is that the resultant of this force system is given 0. It means what, now we will start solving this problem from this end, that is from this step 4. Then as we know resultant generally what is our procedure in our earlier problems, what we have listed out is first of all the table we have listed for force, then just have listed all angles theta with respect to x, then we have calculated x component, then we have calculated y component. Okay, so in this case also we can proceed with whatever data is available with us, and the steps, how much of the steps we can complete, that much steps you should complete. So it means what, with the available data we can list out all these forces, we can calculate theta of all forces, whether this magnitude of this force is known or unknown, but at least we can calculate their theta also, we can calculate their x component and y component also. So in the conventional way what we are calculating, the same way we have to formulate this problem, and the same way we have to get the equation. Now what we will be doing here, at last as and when we have calculated this thing, finally we have calculated summation of f of x here and summation of f of y over here. So this is summation of f of x and summation of f of y. As we generally located that summation of f of x and summation of f of y are nothing but the components of this resultant. So whenever we have calculated summation of f of x and summation of f of y, the summation of f of x and summation of f of y are nothing but the resolve component of this resultant. It means what, instead of these two forces we have replaced these two forces by one force, and that is nothing but R. Okay, now this way we have we just reached up to this resultant and its inclination. Now in reverse, for this kind of problems where resultant is given and we have to find out some of the missing components or missing forces. So what we can do, as it is given in this problem, resultant of this force is given 0. It means what we can take, this R is equal to 0 we can take. So if this R is equal to 0, consider this as if it is one force. Okay, as if it is one inclined force of 0 magnitude. So if this force we have to resolve, then this force will become, that is, whatever will be the magnitude, this force, it means what, resultant into cos of theta will be its x component, and always we know x component of the resultant is nothing but sum of all forces along x direction. So we can equate this thing with equal to summation of f of x, and as it is given in our problem, this is equal to 0, because if R is equal to 0, whatever may be the angle that R is making with respect to x or y, ultimately the total term is going to be 0. So this resultant or summation of f of x will be equal to 0. It means what, reverse we are going, that summation of f of x will be equal to 0. In the similar way, the y component of this resultant will be equal to R sine of whatever angle it is given, and we know whatever angle it is given, magnitude of this resultant is at least given 0. It means what, this total term will come 0. It means what, now we can put up summation of f of y equal to 0. Okay, now once we are having these equations, we are not at all applying any different method here. Okay, we are going with the conventional method only. So only thing is, whatever parameters that we know, that parameters only we are using. First of all, we'll list out all these forces. Now as usual, all forces, that is 40 Newton force, then 50 Newton force, then 30 Newton force, then P, which we don't know but still we can list out this force, then Q. Okay, so as usual we just have listed out all these forces. Now we can list out all the angles. Angle of this 40 Newton is 60 degree with respect to x-axis. Angle of this 50 Newton force, this 50 Newton force is making an angle of 90 degree, and as I said that if any force is acting in y direction, we should list out that y component only, that is its y component will be 50 Newton. Now I'm not going to calculate that by using that f cos of theta, f sin of theta. So straightforward, that magnitude will be 50, and this x component for this 50 Newton force will be equal to 0. Then same way 30 Newton force is making an angle 0 and which is acting along x direction. So we will only list out the x component, and that x component will be equal to 30, and it will not be having any y component. It means what, for y component we will have magnitude 0. Okay, then P force is acting in y direction. It means what, it is also having an inclination of 90, and so that its x component will be equal to 0 and y component will be equal to the value of P. Q, once again Q inclination is 20 with respect to x and its component. Now similar way, the x component of this force 40 Newton and its x component. So this 40 Newton force can be resolved along its x-axis in the first quadrant. So I'm going to resolve it here only. So this will be its x component, and with the value of 40 cos of 60, and as well it is acting along the positive direction. It means what? Sign convention for this component will be positive. So I will list out this thing here, that is 40 cos of 60 and 40 sine of 60. Okay, now the sine of 60, it means what? The sign convention for its y component, 40 sine of 60 is, this is what its y component, and this y component is for this force 40 Newton. So that y component will be 40 sine of 60, and it is acting along the positive direction of y axis. So that's why here sign convention will be positive. Now that about 50 Newton, this 50 Newton force is acting along positive y axis. So that's why sign convention here it will be positive. 30 Newton force is acting along the negative direction of x axis. So this x component we can write down here as minus 30. P force is acting along the negative direction of y axis. That's why P we are going to write down, or y component of this P we are going to write down as minus P. Same way, if we are going to resolve this force Q, that is Q force is here in fourth quadrant, so its x component we can resolve this way, that is theta is given 20, so its x component will become Q cos of 20 and y component will become Q sine of 20. Sign convention, this x component is acting along positive x axis, y component is acting along negative y axis. That is, if we are going to complete this x and y axis, so this way, this is the positive x axis, positive y axis, negative x axis and negative y axis. So now you can just write down here this angle Q cos of 20 with sign convention positive, whereas this sign convention for this y component Q sine of 20. Now all these things, all these terms we have listed here into our table. Now all these terms or x component, when we are going to add up, that we are going to equate with equal to 0, and the reason behind that, already resultant is given 0, so we have listed that summation of f of x will become 0 and summation of y will become 0. Okay, now same way, so we will build one equation, or we will formulate one equation, and by using these two equations we'll see what terms we can get. So from first part, that is summation, or we can write down this equation as 40 cos of 60 plus 0 minus 30 plus 0 plus q cos of 20, and that is equal to 0. So this will be what our first equation. Okay, same way, and this equation we got from first condition, that is summation of all forces in x direction is equal to 0. Okay, now same way for second condition, summation of all forces in y direction is equal to 0, and for that also we will get this equation, that is all terms we are going to add here. So this way now we got this second equation. Now simply by observing, so keep on going calculating the things, and automatically will come to know about the required things. So once again we'll simplify this first equation, that is after simplifying this what we will get is, so let's say I will add up all these terms first, that is this constant term, and we'll keep this, there's only one unknown. If you see in this equation there's only one unknown, so from this equation when it be possible we will get this value. So what I can write down is q cos of 20, this term I will write down here, q cos of 20, and addition of all these terms. Once again be careful while entering these values in your calc, that is 40 cos of 60 plus 0 minus 30, okay, plus 0. So I will calculate it, and this value comes here minus 10. So I will write down that value as minus 10. This is equal to 0. So that what we can get, one equation we will get, that q cos of 20 is equal to 10 is the first equation we got. Same way here also we will get one equation. First of all, add up all these constant terms. Now here in this equation p and q are unknown, so keep that terms as it is and see what else thing we can do with the available data or whatever values we got earlier. So we will add up all these things first. That is 40 sine of 60 plus 50, then we'll keep all these things as it is, so equal to 84.64. so 84.64 minus p minus q sine of 60 is equal to 0. Once again we can simplify this equation. So that is, I will put all these terms here, minus p minus q sine of 60 is equal to minus of 84.64. Simplifying this, I will just remove this negative sign from here. That is, this p plus q sine of 60 will be equal to 84.64. So this is the another equation we got. Okay, now from equation 3 and 4, and this is what equation number 4. Now once again from this equation we can write down here, from equation 3 what we get, q cos 20 is equal to 10. So that value for q we can get 10 divided by cos of 20, and that is equal to, so calculate this value first. 10 divided by cos of 20, 10 divided by cos of 20, 10.64 Newton. This is the value for q. Okay, so from third equation we got value for q as 10.64, and now from equation number 3 or 4, the equation 4 is p plus q sine of 60 is equal to 84.64. so that p we want now, because q already we have calculated. Q p plus 10.64 into sine of 60 is equal to 84.64. now if you observe in this total equation there's only one unknown, so this value we can get directly as p is equal to, calculate this thing, that is 84.64 minus 10.64 sine of 60, this will be 75.4. so this way we have to solve all these questions wherever generally these kind of questions are asked into the university exam where resultant is given. Now here in this case that resultant was given 0. Sometimes in some cases that resultant is given, that resultant is acting along x-axis and its magnitude is given. So in that case, same way, instead of taking this r is equal to 0, what we can take, r component, or the accordingly we can take that resultant the way it is given, and once again we can split it into its two components. So we will I will just share with you all those cases. Will not solve that problems completely, but at least I can discuss that problem and the method with which we can solve this thing. Definitely the method to solve that problem will remain same that we have solved now. So just go through this method and you can solve any problems on the concurrent force systems. Okay, so this is all about our first part, concurrent force system, and we are almost done with every kind of every type of case. So in our next coming sessions we'll be starting with our new topic, that is resultant of non-concurrent force systems, and I'm going to provide these notes and some exercises, the examples that you should solve on this particular topic. The link I'm going to provide into the description, and for more details and for the regular lectures, do share, subscribe for the lectures, so that you will get an intimation for my new lectures. Thank you.